Hello everyone. So today I'm going to talk about server-sent events, which is handling events in JavaScript on the client side, where the events literally happen on the server. My name is Kornel Leszczyński. You might know me from apps like ImageOptim and image optimization in general, but I also do JavaScript, not just images. So that's why today's talk. Server-sent events is now kind of old API. It's older than its competitor WebSockets. And I've been involved in designing the API at What Working Group quite a while ago. So let's just start. You probably know the AJAX, the XML HTTP request, which is simple, just downloading a single file over HTTP. On the other end of the spectrum, we have WebSockets, which is a completely custom protocol with a dedication permanent connection to the server where you can exchange messages in two directions. However, between those two, between just a simple download on a HTTP connection and a full-blown custom protocol, there can be a simpler alternative, which is server-sent events. Server-sent events started as a hack. It used to be called Comet or long polling, where instead of downloading a file from the server immediately, the server wouldn't respond until something happened. So to the browser, it looks like the file is just taking a very, very long time to respond, but the server is deliberately not responding until it has something to say to the client, and then it sends the rest of the message and closes connection. So that was long polling, and this sort of a hack got fully standardized into server-sent events API, and even extended that not only you just send one thing and close connection, but the server can keep responding and responding and responding on the same HTTP connection. What would you use it for? For example, you can implement your own Slack clone. Server-sent events is just from the server down to the client. So if you want to send a message to the server, you still have to use the classic AJAX request or a form or whatever you use to communicate with the server up to the cloud. But then, with server-sent events, you can make all the clients, all the other windows, all the other users, everyone else subscribe to listening to the events that happen on the server. So the server can say, hey, there's a new message, there's a notification, something happened. And then all the clients will immediately, in real time, get the message. You can observe logs on the server in real time. And probably the biggest user of the server-sent events API specifically is GitHub. I don't know if you noticed, but if you keep a GitHub window open and a push new branch to the repository, that message will pop up automatically. You don't have to refresh. GitHub.com will detect that you've pushed to your Git repository using command line Git or an application or anything else, and notify all your open browser windows in real time that you've just changed something, that there are new files, there's a new branch, or that you've posted a comment. And it pops automatically because GitHub uses server-sent events and makes all your browser windows always subscribe to events that happen on the web server. From the client side, it's a very minimal API. There's event source constructor. So you subscribe to a stream of events giving URL on the server. I'll briefly, shortly describe how to what to send from that URL, but you'll create your own server-side endpoint for messages. On the client side, you just subscribe to that endpoint and you get a source event object, and it will fire a message event every time the server says there's something new that happens, and you'll get event data which is arbitrary string. Usually you can just send a string of JSON and decode that JSON from the server. There's also a bit more that you can do, but that's the basic if you just want to know something happened on the server now. Differences between WebSocket and server-sent events are mainly compatibility. So WebSockets used to sound like a nice solution a couple of years ago, but a thing happened. HTTP2 is now very common, and it happens that WebSockets are not compatible with HTTP2. WebSockets were a hack on top of HTTP1, and that hack no longer works in the HTTP2 world. However, server-sent events on the network level look like it's just a file download, a regular file being downloaded just very slowly, one line at a time. Server-sent events continue to work with all web servers, web proxies, most CDNs, everything that you can just distribute a regular static file over. Then it also is most likely to be compatible with server-sent events. And compared to hacks built on things like XML HTTP request or never-ending iframes or slowly downloading scripts or so on, is that the browser knows server-sent events are dedicated to sending events from the server, so it can be smarter about managing those connections, avoiding blocking other HTTP traffic that would otherwise wait on that connection, or reuse one connection across many event objects. So what you're sending from the server is a text file. You have to set MIME type that's called text event stream. And then the server sends a line starting with data colon. Those 5 bytes are the entire overhead of your message. So the protocol is actually quite efficient. After that, it's arbitrary data that you want. It can be plain text, it can be JSON string, whatever you find convenient, and a blank line. Blank line tells the browser, I finished, that's the whole message, fire an event now. So the cool thing is, the whole protocol can be basically described on a single slide. Compared to WebSockets protocol, which is a binary data protocol with special framing, compression, many other features, which are like 50-page spec. So if you were building a WebSocket server from scratch, that's actually a huge challenge and a library. And to use WebSockets on a client, you'll also probably want to have some kind of a library that adds sugar on top of the raw API. On the other hand, server-sent events are just a plain text protocol sending line of simple instructions. So I can tell you everything about the protocol right now. So as I've mentioned, every line starting with data is a bit of the event that you're sending. You can assign an ID to every event. If you assign an ID, the browser will remember the ID of the last message that it has seen. So if the connection is lost, the server will try, the client, the browser, will try to reconnect the server and will tell you the ID of the last message that it saw. This way, your server can use some kind of an ID that you can get from a database or a timestamp or something like that, and you keep track of how many messages the client has seen. And in case of interrupted connection, you can gracefully resume sending messages from where the browser lost connection. This way, you don't lose any messages. And this also is robust against data loss. You don't have to worry about user having a mobile connection and going through a tunnel. It will lose connection, but the browser will automatically reconnect, tell you I've last heard from you around that time, and your server can read it and just resume as if nothing happened. And on the client side, you don't even have to see those IDs. On the client side, the same event source object will just continue firing messages for you, which is really nice. As I mentioned, the browser will automatically retry connecting to the server in case the connection is closed. And you can set a delay in milliseconds, how much the browser should wait before trying to reconnect. It can be something like 1 second to be almost instant. You can make it longer if you just want the browser to go away. For example, if you have too many users coming to your website at the same time, and your web server just cannot handle so many connections, you can tell them, like, go away, wait 30 seconds, I cannot serve you right now. You can name your events. By default, the event source object fires message event. But if you want to be fancy and categorize your events into different types, you can, before sending data, you can name your event anything else. This way, for example, you can have several components on your page share the same event stream, but each component getting its own kind of a message. Or you can just keep sending the anonymous generic message, and as a data, use JSON string and identify what happened there in your own application-specific way from the data itself. As I've mentioned, if you're trying to decide whether you use WebSockets or server-sent events, it's mostly about simplicity and compatibility. If you use WebSockets, it might be so much hassle that you'll decide to outsource it to a third-party company that probably happens to sponsor this meetup. But server-sent events are so simple that you can reasonably roll them out yourself, and you don't even need a library. It's not like npm install this special thing for server-sent events. If you're using Node.js, it's literally set the content type and just keep sending lines of text. In Node.js, you don't even have to flush the connection. It's different if you use another programming language or some kind of another interface that buffers. And speaking of buffering, buffering is the most annoying thing about server-sent events when you try to deploy them. So for example, Nginx, a server, by default will try to buffer 8 kilobytes of data. But if you're sending event that is just 100 bytes of data, well, it's going to sit in the buffer waiting for more data to be sent eventually, which is not good when you want this data to reach the browser immediately. So specifically for Nginx, you can send a HTTP header that disables buffering or set a configuration option that disables buffering. If you're using other proxy servers like HAProxy or something like that, check the documentation for your proxy. If messages are not arriving, it is probably just due to buffering. And in other languages, like PHP, you have to call a flush function that actually tells it to start sending data. Though I really recommend using Node.js because if you're using PHP, your server will look like that. With server-sent events, there's a permanent TCP/IP connection open for every visitor of your website. So if 100 people are visiting your website at the same time, you will have 100 connections. And if those people open three browser windows at the same time, you'll have 300 connections. So with something like Node.js, not a problem at all. You can have 10,000 connections, and they'll be handled fine as an event queue. But if something like Apache plus PHP, that setup assumes the connections are short-lived, and you have a limit. Still, like even if you have PHP or Ruby or something like that, that's not designed for permanent connections, you can still use server-sent events for your smaller scale usage. For example, if you have admin interface for your website, you can have real-time notifications, real-time updates, or watching the status of your server, or new customers, or whatever you want to know to update on your website as soon as it happens. It's just, that will be prepared for 20 connections, not 20,000 connections. Still, if you have problems with overloading your servers, as I mentioned, server-sent events automatically reconnect to the server. You don't have to do anything. That's the beautiful thing. You don't have to manage errors with server-sent events. The browser already does it for you. It will do its best to keep connected. So you can just tell clients to disconnect and retry after a delay. And you can keep increasing this delay as the load on your server increases. And print retry, new line, and close connection. So the client will remember how long to wait. The connection will be closed, so your server doesn't have to handle the connection anymore and can serve other clients. But the client will retry after a while and see, knock again. Can we talk now? So that's a very, very good way to scale beyond whatever your server can handle by default. In terms of deployment, the story for server-sent events is the classic one, which is all the nice browsers support it, and support it for a long time now. So you don't even have to worry about the version of them. They all do, even on mobile. Except the classic villains. It's not supported in IE. For Edge, it's under consideration. So maybe supported, maybe not. The good news is, because the protocol is so simple, and it's so similar to long polling, there are polyfills for IE and Edge that basically work exactly as the native API. It's just one library on the client side that will make it work. So that's it for the server-sent events. I'll add a little bit of history for this. The whole idea about server-sent events started on one working group when somebody said, wouldn't it be cool to remotely control a web page? And that's why it's events, and that's why you can define your own type of event, because the original idea was to send mouse clicks and keystrokes to the web page. The idea is you just add event source tag with a URL for the server to remotely control what happens on the page and send mouse click, move mouse, do this, do that. That remote control idea did not really catch on. But still, you can send your own events in a currently completely native, purely JavaScript API. So that's it. If you want the slides, they're on my site. And now, questions.
So with the lack of support in IE, are there any libraries that you're aware of that will abstract things out so that it uses WebSockets or server-side events based on the client and what it supports?
If you Google for a server-sent events polyfill, the first result on is GitHub with a really nice, well-designed library. There's also a small polyfill written by Remy Sharp. and both of them use XML HTTP request, and they can stream and parse the request on the client side. So they're fully polyfilling the same API, and it's just a few kilobytes. So IE support is not a big deal.
Okay, cool.
Is WebSockets not necessarily the obvious choice for two-way communication then? When would you...
WebSockets is an obvious choice. So if you need a two-way communication, for example, you're implementing a first-person shooter and need super twitch quick upload of every keystroke to the server, then yes, WebSockets is the right choice for that. A server send events is from the server down to the client in real time, and only that direction. So if you're implementing a chess game, then you can use server send events. If you're implementing first-person shooter, then use WebSockets.
Thank you very much.
Yeah, thank you.